Okay, so today our math goal is comparing fractions. All right. So, what I know, what do you know about fractions? So, write down your math goal and write down what you know about fractions and then come back to me and then we'll share tomorrow. Okay. All right. So, do you remember less than, greater than, and equal? That's what we're going to be using today to compare fractions, okay? So, before we get started, let's remember how to use those symbols, okay? So, these aren't fractions, these are just regular numbers, right? Where would the fraction bar go in this example? Not fraction bar. What symbol would we use and where would it go? So, how do we compare these? Do you remember? We start comparing what? Place value. That's right, the hundreds, right? So this one has a 4 in the hundreds. This one has a 5 in the hundreds. So which one's bigger? 546, correct? All right, try this one, okay? And then come back to me. Okay, if you said 3,200, you'd be correct. Even though they both have a 3 in the thousands and the hundreds, this one has a 2, that one has a 0, so 3,200 is bigger. All right, so we remember that? All right, let's try that with some fractions. All right, so what symbol would we use? We have 3/5 and 4/5. So what symbol would we use and why? What do the fractions have in common? So let's look at it. 3/5, 4/5, what do they have in common? That's right, they have the exact same denominator, right? They have 5 as a denominator. So which one is bigger and why? So if you're not sure, let's look at our fraction bars. Okay, and in the next slide, I have my fraction bars. So this is 3 out of 5. This is 4 out of 5. They're both broken up into 5 equal pieces. This one has 3 out of 5. This one has 4 out of 5. So this is an important rule to write down. When we have the same denominators, look at the numerator and see which one is larger. So this one tells me I have 4 things out of 5 things. This one's actually more than 3 out of 5 things, right? Think of it as food or sharing something. Here I have 4 things out of 5 things. So this is more, this only have 3 things out of 5 things. So it's less. So pause the video and write this down. Okay, let's take a look at this one. What symbol would we use and why? We have 2/5 and 2/7. So what do they have in common? So this one's a little bit different, right? What do they have in common? That's right. If you said the numerators are the same, you would be correct. So what happens when the numerators are the same? So let's take a look at that one and see what that would look like, okay? So here we have our, oh, come on. There it goes. So this case, this is broken up into 1, 2, 3, 4, 5 equal pieces. This one's broken up into 1, 2, 3, 4, 5, 6, 7 pieces. Here I have 2 out of the 5, and here I have 2 out of the 7. So this is an important rule to write down. So which one's bigger? 2/5. You're right. So if we have the same numerator, look at the denominator and see which one is smaller. The smaller the denominator, the bigger the fraction. Why? Because it's broken up into less pieces, right? You have the same, you have 2 out of 5, it's only broken up into 5 pieces. This one you have 2 out of 7, it's broken up into more pieces. So it's going to be less. So pause the video and write down this rule, okay? All right, so let's take a look at this one. Let's try some. Okay, so what symbol would we use and why? 4 out of 9 or 4 out of 7? So first, let's say, do they have anything in common? Yes, right? The numerator. They have the numerator in common. So do you remember what we said about if they have the same numerator? What do we do? Same numerator, look at the denominator, right? The smaller the denominator, the bigger the piece. So 4/7 is bigger. Think about it this way. This is divided up into 7 pieces and you're getting 4 of the 7 pieces. This one's divided up into 9 pieces and you're getting 4 out of the 9. So you're getting more with 4 out of 7. Okay, let's look at this one. 2/10 and 1/10. What do they have in common? The denominator. Good. If you said denominator, that's correct. So this one's opposite, right? Now I'm going to look at the numerator. The bigger the numerator, the bigger the fraction, because these are divided up into the same 10 equal parts. Here I'm only getting one piece out of the 10 equal pieces. Here I'm getting two pieces out of the 10 equal pieces. So 2/10 is bigger. All right. All right, so what symbol would we use? So you try these on your own. So pause the video and write down 1/5 greater or less than to 1/3 and 5/8 greater or less than to 6/8. So write these down and then come back and then we'll check. All right, if you said 1/3 is bigger than 1/5, you'd be correct because you have 1 out of 3 pieces. These are bigger pieces. 1 out of 5, these are smaller pieces, right? 5/8 and 6/8, what's bigger? Well, I've looked at the denominator, they're both in eighths. So I know that 6 out of 8 has got to be bigger than 5 out of 8. All right. Okay, try some more. What symbol would we use and why? 3/7 or 3/8, 5/7 or 6/7. Write these down and then come back and then check your answers. All right, so if you said 3/7 is bigger than 3/8, you'd be correct because they have the same numerator. So I'm looking at the denominator. Remember, the smaller the number in the denominator, the bigger the fraction. Okay. Now this one, if you said 6/7 is bigger, you are correct. They have the same denominator. So I'm going to look at the numerator. The bigger the numerator, the bigger the fraction, because here I have 6 out of 7 pieces. Here I only have 5 out of 7. Okay. Okay, what about this one? What symbol would we use? 3/4 or 5/8? What is bigger? Looking at the numerators, they're not the same. Looking at the denominators, they're not the same. So that's not going to help me, is it? So, what could I do to solve this one? Do you have any ideas? Well, there is one easy way to do this that will always work. So if your numerators or denominators are not the same, there is a trick to solve these, okay? All right, so do you remember this from fourth grade? I know that the fourth grade teachers used this in the past, cross multiply, right? So we're gonna write this down, write this example down, because this will work for any fraction to compare any fraction. This is my go-to. So this one is like the main one. So put a star next to it. This is the one that I use all the time. Okay, what symbol would we use? So 3/4, 5/8. You circle these. So we're going that way. So remember that way. We actually got to do it the other way, right? Because it's weird the way my camera is. So I like using my hand movements, but I'm trying to see. It's kind of funky, right? So the 4 goes up to the 5, but it's opposite. Oh, I don't like this. Let me see if I can reverse my camera. I'm not sure. Okay, sorry, I tried reversing my camera. It's not working. So just know 4 goes to the 5 that way. And I like using my hand movements, but it's going the opposite way. So it's kind of weird. Okay, 4/5. So I'm going to take the 4 and the 5. I'm going to multiply. 4 times 5 is 20. And I'm going to go the opposite way. 3 times 8 is 24. So that goes on that side. I need to find a common denominator. What's my common denominator? The easiest way to find a common denominator is just to use the product of both denominators as the common denominator. So 4 times 8 is 32. So in essence, I am making equal pieces. So I'm making them both into 32. 4 times 8 is 32. So I'm 32, my common denominator, 32 common denominator. So basically what I'm doing is I'm saying to use the cross multiplication, basically what it is. So I got 32 for my common denominator, and then I'm saying 32 times what number is gonna give me, sorry, 4 times what number is gonna give me 32. So 4 times 8, right? So, okay, so in essence, what I'm doing is I found 32 as my common denominator. So 4 times what is 32, 4 times 8. So remember, whatever I do to the bottom, I do to the top. Whatever I do to the top, I do to the bottom. So if I multiply the bottom by 8, I got to multiply the top by 8. So 3 times 8 is 24. That's how I got that, okay? That's what the cross multiplication means. And it's the same thing for this one. My common denominator is 32. 8 times what is 32? 8 times 4 is 32. So if I multiply the bottom by 4, I got to multiply the top by 4. Whatever I do to the bottom, I got to do the top. Whatever I do to the top, I got to do to the bottom. So 8 times 4 is 32. 5 times 4 is 20. So that's basically why we're able to do the cross multiplication. That's why that works, because you're finding a common denominator. So now that I have equal pieces, right? Now I can compare because my denominators are the same. I have the same denominator, so what does that mean? All I got is look, it's the numerator. The bigger the numerator, the bigger the fraction. So 3/4 is bigger than 5/8. This one will always, 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 always work. So make sure you understand this. If you don't, rewind it, the video, until you understand, because the cross multiplication, finding the common denominator, always, always, always works. Oh, and FYI, this one is very important that you do know it, because this is leading up to our actual fifth grade standard. So our actually fifth grade standard, what we're leading up to is adding and subtracting fractions with unlike denominators. So this is one way to find a common denominator. Okay, so make sure you understand this. All right. All right, go ahead and try one. What symbol would we use? So again, use any method that you want and then come back to me. All right, so if you said 4/5 is bigger, you would be correct, okay? So because the numerators are not the same, the denominators are not the same, I cross multiplied, okay? So I wrote them up here so you could see it better. So 4/5, and I got my common denominator of 35, because 5 times 7 is 35. Remember, I find my common denominator by multiplying both my denominators. 5 times what is 35? 7. So if I multiply that by 7, I'm going to multiply the top by 7. 4 times 7 is 28 out of 35. 28 out of 35. And then this one, 7 times what is 35? 5. So I multiply the top by 5. 5 times 5 is 25. 25 out of 35. So that one is bigger. So 28 out of 35 is bigger than 5/7, than 25 out of 35. Because that makes it easier to compare, right? When they're this broken up into the same amount of pieces. Okay, try another one. What symbol would we use? Write it down in your math notebook. 7/9. What's bigger, 7/9 or 5/6? Write it down, figure it out, and then come back to me. All right, so if you said 5/6 is bigger, you'd be correct. So what I did is I cross multiplied, because I saw that my denominators were different, my numerators were different. So I used my denominators from both to cross multiply. 6 times 9 is 54, right? So that's my common denominator. So then I rewrote it up here so it's easier to see. So 6 times 7 is 42, so that goes 42 over 54. 9 times 5 is 45, 45 over 54. So in essence, remember, 6 times what is 54? 6 times 9. So if I multiply this by 9, I got to multiply that by 9. So 5 times 9 is 45. And then same thing with the opposite. In essence, that's what the cross multiplication is. So to get 54 over here, I did 9 times what is 54? Well, it's 6. 6 times 9 is 54. So I multiplied this by 6. And then I multiplied the 7 by 6. 7 times 6 is 42. That's why the cross multiplication works. Okay? Okay, there's a couple of other ways to do this. So these are the special cases close to 1/2. So if you have a fraction that's close to 1/2, that's another way to be able to do these. I still prefer the cross multiplication, but I'm just going to show you these because some of you may like this, or some of you may be doing it this way. So we have 5/8 and 2/5. So if I have my number line here, Here's my 2/5. So, and here's my 5/8. So I know that half of 8 is 4/8. So I know that this is more than a half. Half of 5 is what? 2.5, right? So it's a little bit less. So I know that this is more because it is more than a half. Half would be 4 out of 8, and this is not even a half. So I know 5/8 has to be bigger. So 5/8 is greater than a half, and 2/5 is less than 1/2. So 5/8 is greater than 2/5. So that's another way that you can do these. But if this confuses you, stick to your cross multiplication. That will always work. Okay. Okay, here's another special case, a special case, not place, a special cases when it's close to 1. And this is called using benchmarks because we're using benchmarks. We're using the benchmark of 1 to see which one is closer. So 5 out of 6 or 6 out of 7. So here this number line is broken up into 7 pieces. And I have 6 out of 7 of it. So it's right here. This number line is broken up into 6 equal pieces, and here's 5 out of 6. So what's closer? 6 out of 7, right? Because this is broken up into more pieces and you're getting 6 of them. This is only broken up into 6 pieces. Even though this is only one away, that's only one away too, right? But this was into smaller pieces, so you're getting more of it. So 6/7 is closer to 1, therefore 6/7 is greater than 5/6. So that's another way to look at this. But if this confuses you, stick to the cross multiplication. All right. All right. So your takeaway from this lesson: comparing fractions to 1/2 and 1 do not always work. We didn't try them in the video yet, but we're going to try some in class. Comparing fractions, if you want to compare it to the half and to the 1, it doesn't always work, but finding a common denominator will always, always, always work. And so we will see some in class that if you try to compare it to a half using the benchmark a half or using the benchmark 1, it doesn't always work, but finding the common denominator always, always, always works. So really, which one do I want you to use? Find the common denominator. You will not go wrong because you're breaking it up into the exact amount of pieces, equal amount of pieces, and it's easier to see which one's bigger. Okay, so that one always works. So write down in your math notebook what you learned today. Proof of learning, show me some examples. And if you have a reflection or a question, write that down, please. All right.